in the yesterday's session, we have started the JVM architecture and we have seen the basic, what are the different topics. Okay. Here in this JVM architecture, 3 different parts. Okay. So first part, what happens when the class file is get inputted to the class loader subsystem, different subparts of the class loader subsystem, that is how the loading is done, how the linking is done, and how the initialization process is done here in this JVM architecture. Okay, anyone has any doubt till here? किसी को कुछ डाउट है JVM आर्किटेक्चर के फर्स्ट सब पार्ट में क्लास लोडर सबसिस्टम, 3 सब पार्ट्स ऑफ इट, लोडिंग, लिंकिंग एंड इनिशियलाइजेशन, क्लियर विथ everything, right? So today we are going to see the remaining part of the JVM architecture, that is runtime data areas. Okay, so first we are starting with the runtime data areas. This is the second part of the JVM architecture. JVM architecture has the second part, that is the runtime data areas. Yes.
Can you give me please a quick recap of the top one?
Okay. So we have seen the JVM architecture first subpart, that is a class loader subsystem. We are getting the input, whatever the class file gets created, then that class file gets inputted to the class loader subsystem. Class loader subsystem first has the loading part. First subpart is loading. There are 3 types of loaders: bootstrap class loader, extension class loader, and application class loader, right? So how the loading is done, that we have seen. So bootstrap class loader is a parent of extension class loader. Extension class loader is a parent of application class loader. So whenever the class file gets inputted to the as an input to this class loader subsystem, it will request to load the class. First, the request goes to the application class loader, then that request is delegated to the extension class loader, and it is again delegated to the bootstrap class loader. So first, the bootstrap class loader searches here the path, that is JRE path. It is known as a bootstrap class path for the same dot class file. If it is available, that gets loaded into your JVM. If it is not available, then the same request delegated to the extension class loader. Extension class loader again searches that dot class file here in the extension class path, that is nothing but the ext folder. I have already shown these folders yesterday. Okay, so in this class path, if it is not available in the same class path, then that request extension class loader delegates that request to the application class loader. So application class loader is nothing but where we are storing our application. Okay, so that is nothing but your application class path. This JVM will search the application, the dot class file in the application class path. If it is available here, then that dot class file gets loaded into the JVM itself. If not available, then we will get the error messages like, or the exception, no class definition found, no such class found. Okay, so this is the class loader subsystem. First step, loading. Then we have seen linking. In the linking, verify, prepare, and resolve. These 3 steps are there, that is verification, preparation, and resolution. So verification is nothing but whatever the bytecode is generated or the dot class file is correct or not, that is that is done here in the verification phase of the JVM. Okay, if the verification is correct, then the dot class file is loaded successfully. Then the prepare statement, whatever the static memory allocation will be done here for static variables only. Okay, so this is only for the static part, nothing else, and it will be assigned some default values. Then the third one is resolution. Resolution will the symbolic memory references means if we are using some variable name, so whatever the value for that variable, that will get replaced. The original value of that particular variable, that gets replaced here in the method area. So method area is we are going to see today. Okay, the third step or the third subpart of the class loader subsystem is initialization. So in this is the final phase of class loading. Okay, so what happens here in the initialization process, whatever the variables, static variables are stored, the memory was allocated for them. for those variables, actual values or original values gets stored in those static variables. Okay, and the static block gets executed. This is what the third step, initialization, final phase of class loading. So this is what we have seen yesterday, class loader subsystem, 3 different parts, loading, linking, and initialization. Clear? Any doubt? This is a quick recap. Okay. So today we are going to see the runtime data area, that is nothing but the second subpart of the JVM architecture, which has several different parts, subparts: method area, heap area, Java threads, program counter registers, native internal threads. Okay, that we are going to see one by one today. So as you can see here, runtime data areas are divided into 5 major parts. So what are those? Method area, this is most important. Runtime data area part is most important because here the actual memory was allocated for the different variables according to the data types and all for threads. So that's why this is the important one. So you need to understand this runtime data area very neatly. Okay, आपको अच्छे से समझ में आना चाहिए. So first major part is method area. Second is heap area. Okay. Third one is stack area. Stack area is, again, we will see what are these things. Fourth one is PC registers, and last one is native method stack. Okay. So one by one, we are going to see what is the method area, what is the heap area, and all those things. Clear? So here, runtime data areas. Method area, as I said, it is divided into 5 major components. सबसे पहला है आपका method area. Method area, what it stores? Method area means all the class level information like class name. Okay, I will write down here. What are the information we are storing? Like the class name. Okay, then immediate parent. Immediate parent of that particular class, methods, okay, variables, information. So all the class level information, that is nothing but the class name, immediate parent name, parent class name, you can say, methods, different methods stored into that or written into that class, different variables that are stored into that class, as well as we are going to store the static variables information also here in this method area. Okay, static variables, the class level information includes class name, immediate parent class name, methods, variables, all these information we are storing into the method area. Okay, as well as static variables. Okay, as you can see here, the static variables are also stored here in this method area. So there is always only one method area per JVM. ठीक है, एक ही method area होता है, only one, ठीक है, per JVM, and it is always shared resource. Why shared resource? Because all the classes, whatever the classes you are writing, suppose you are writing 50 classes, okay, so all these 50 classes information, all these information with the static variables are stored into one method area itself. ठीक है, सारा डेटा एक ही जगह पे स्टोर होता है, दैट इज नथिंग बट द मेथड एरिया. सो ये आपको इंटरव्यू में भी पूछा जाता है. यू मे गेट आस्क्ड व्हाट इज मेथड एरिया, वेयर दिस वेरिएबल्स गेट स्टोर्ड, वेयर द मेथड्स ऑफ द क्लासेस गेट स्टोर्ड, that you need to understand where we are storing it. It gets stored into the method area by default by the JVM itself. ठीक है, JVM के थ्रू आपका मेथड एरिया में ही पूरा डेटा स्टोर होता है, क्लास लेवल इंफॉर्मेशन. ओके, देन नेक्स्ट वन इज, it is again, remember that this is only one method area per JVM and it is a shared resource. ठीक है, So method area always stores these details. What details? Nothing but the class information. Okay. So it is nothing but fully qualified name of the class, immediate parent class name, then whether that class is interface और enum और class itself. ठीक है, ये आपको डॉट क्लास फाइल जो है वो क्लास है, इंटरफेस है या फिर enum है, वो भी आपको यहाँ पे दिखता है. As well as modifiers, variables and method information is also stored here into the method area. ठीक है. Next one is the heap area. So heap area, whenever you are creating any objects of that class, ठीक है, whenever you are creating any objects of the class, that object R and its corresponding instance variables arrays will be stored here into the heap area. That means okay, so here heap area, whenever you are creating objects of any class, okay, any class objects, then if we are storing objects, that means its instance variables, instance methods are there, right? Any class has instance variables and instance methods are there, right? So whenever we are using the object or creating the object, that instance variables, instance methods are also stored in the heap area. Okay, so instance variables and instance methods arrays are stored in the heap area. There is also one heap area per JVM, and since the method and heap areas share the memory for multiple threads, the data stored here is not thread safe. Okay, why it is not thread safe? Thread safe क्या होता है? What is mean by thread safe? That we will see later when we will learn the multi-threading point. Okay, so just remember this now. In the heap area, all objects related information, that is nothing but the instance variables, instance methods, arrays, etc. get stored into this particular heap area. This is also only one per JVM, nothing else. Okay, and as the method area and heap area, ये भी एक ही है, ये भी एक ही है. So कितने भी objects आप create करोगे, all those get stored here in the heap area itself, and it is again the shared resource. Okay, so method area and heap area are shared resources. Those are shared among all the classes, all the objects. Okay, third one is the stack area. So stack area is here. You can see stack area has different threads. It has a structure where we are storing a stack frame, LVA, OS, and FD are these. What are these? I will explain. Okay. So stack frame, each and every thread gets memory allocated here. Okay. So the JVM performs two operations on the stack. The operations are nothing but push and pop. Push and pop. Okay. Push means we are storing the data. Pop means we are deleting or retrieving the data. Okay. Push means insert and pop means delete or retrieve. So when thread, whatever your application, whenever you are creating any application that creates one thread each and every time, for each and every program, we have a thread created by the JVM itself. Okay. So that thread, जो भी current executing thread है, okay, whatever the thread which is in execution, the stack associated with is known as runtime stack. Okay, whatever the threads or whichever the thread is currently executing, the one stack is created for that particular thread in the JVM, and the thread, whatever the stack it gets created, the memory gets allocated here in the stack area. That is known as runtime stack. Okay. So what are these different parts here? that we will see. So for every thread, a separate stack, runtime stack will be created. Abhi runtime stack kya hota hai maine explain kiya. For whenever you are creating any program or executing it, so every thread gets created, one thread gets created, and that thread has a separate memory allocation. Yes, a small program. We can create our own threads also, but by default also the system creates one thread each and every time. Okay, that is a main thread we say. We will see that in multi-threading chapter. Okay, so whenever you are executing a program, thread gets created, and for every thread a separate memory gets allocated into the stack area that is known as runtime stack. Okay, a separate runtime stack will be created. For every method call, one entry will be made in the stack memory, which is called stack frame. अभी हमने देखा था यहाँ पे stack frame है, right? This is here. This is a stack frame. So stack frame contains nothing but each and every method call. Okay, whichever the method call you are calling a method, use that method. Suppose consider that method is main method. Okay. So first we are automatically the main method gets called. Okay. So for the main method, a separate stack frame is maintained or separate runtime stack is created. And in the stack frame, we are storing the called method. Okay. So for every method call, one entry will be made here into the stack frame. ठीक है, stack frame में एक entry होता है, कोई भी method call हो उसका एक method call के हिसाब से stack frame में entry होता है. ठीक है, sorry. So for each and every method call, stack frame is maintained. ठीक है, the memory which is known as stack frame. अभी stack frame में क्या क्या स्टोर होता है, कौन सा डेटा स्टोर होता है. So all the local variables will be created into the stack memory. Okay, local variables means whatever the variables we are going to create into the method. ठीक है, वो मेथड के हम लोकल वेरिएबल्स पढ़ने वाले बाद में, उसमें आपको समझ में आएगा. बट अभी के लिए अंडरस्टैंड ये रखो कि whatever the local variables we are creating inside the method, those are stored into the stack memory. The memory gets allocated here into the stack memory itself. Okay, then with this method call, whatever the intermediate computations or calculations are also there, those are also stored into this runtime stack or this stack frame. ठीक है, runtime stack जो है उसी के stack frame में क्या क्या डेटा स्टोर होता है. पहले तो मेथड कॉल जो होगा उसमें लोकल वेरिएबल स्टोर होंगे, अगर कुछ कैलकुलेशंस आप कर रहे हो तो वो भी स्टोर होगा. ठीक है, वंस द थ्रेड stops or completes execution. Okay, उससे पहले ये पार्ट मैं बताती हूँ. The stack area is thread set since it is not a shared resource. ये दोनों shared है. The method area and heap area are shared. If you are creating 50 classes, all these 50 classes store or uses the same method area. If you have created 50 objects of any class or total of 50 objects in your complete program, then also are in your complete Java. Okay, so those objects are also stored here in the heap area. Those also share the same memory allocations. Okay, so method area and heap area are not thread set because each and every class and objects shares the same area. Okay, the same memory allocations. And the stack area has the different or separate memory allocated for each and every thread. Okay, that is why it is a thread set, because one cannot access other data. Okay, that is why it is not a shared resource. It is a thread set since It is not a shared resource. Okay. Stack area, once the thread stops. Okay. Now, whenever they start execution, this will be stored into the stack area. Okay. Once the thread stops executing or completes its execution, the respective part of the stack gets deleted. That means automatically data stored into this gets deleted. Okay. Whatever the thread, whenever the thread stops or completes the execution, the respective part from the stack is deleted. Once all the calls by the thread are complete, the stack becomes empty. सारे threads का execution complete हो गया तो stack empty हो जाएगा. Okay. Or it is deleted. That means automatically memory will be freed. आपको कुछ करने की जरूरत नहीं है. The data gets deleted automatically. You don't have to do anything. So just before terminating a thread, JVM destructs the stack associated with a thread. And the stack that stores data associated with thread is exclusively available only to that specific thread. This thread data is only available to the specific thread, that is thread 1. Okay. It is not available to the thread 2. The thread 2 cannot access the data from the thread n. Thread n cannot access the data of thread 1. Okay. So whatever the data we are storing here for the thread, that is stored here itself, and that is associated with that thread only. It is inaccessible to other threads. This indicates that data in the stack is thread safe. So data we are storing here, those are thread safe. It is not compulsory for JVM to have contiguous memory allocations. So you can say contiguous means after 1, 2, 3, 4. Matlab, if we are storing the data at 1, you don't have to store the data at 2 immediately. You can store at 9 also. Okay. So it is, we will see that when we will learn the variable part. So the memory allocations is not contiguous here for the stack area. So what is this LVA? LVA is nothing but the local variables. Okay. Then this OS and FD. I will clear this part now. Okay. So the stack frame is divided into 3 sub-entities. That is nothing but local variable array. Local variable related to a method. Whatever the variables we are storing into a method, those are nothing but the local variables. And those variables are stored here in the stack frame as we have seen. Okay. So those are involved in the corresponding values will be stored here. ठीक है. So जो भी उसके corresponding values है मेथड के local variables के वो store होंगे इस local variable array part में. Second one is operand stack. Operand stack is nothing but intermediate operation if you are performing some computations, calculations. So we are using the operand stack. Okay. So operand stack nothing but has the operands plus, minus. You know that, right? Plus, minus, multiplication, division, all these are operands. Multiple operands are there. So if we are calculating something, so for calculations, you need to use the operand stack, like you have to first do the multiplication, then the division, then the minus, and then the plus, right? So ऐसे अगर हमारा sequence है, तो कौन सा ऑपरेशन पहले एग्जीक्यूट होना चाहिए, कौन सा ऑपरेशन बाद में एग्जीक्यूट होना चाहिए, that is everything gets stored here. Intermediate operations get stored here into the operand stack. With the help of this operand stack, we are performing some calculation operations. Okay. So operand stack act as a runtime workspace to perform the operation. And the last one is frame data, FD. FD is nothing but the frame data. All symbols corresponding to a method is stored here. It contains constant data values and a method return data. So if the method is returning some data values, those are stored here into the frame data. Again, some constant values are there, then those are also stored here into the frame data. In case of any exception, the catch block information will be maintained here into the frame data. This exception part, when we will learn exception, then you will be able to understand that. Okay. So this is the second important memory allocation related information here into the runtime data areas of JVM architecture. Okay, understood this these parts till here? Method area, heap area, and stack area. Understood this? Any doubt? Anyone? Okay. The fourth part here in the runtime data areas. Okay, I will explain. Threads part in stack area. So whenever you are calling any method, कोई भी method हो, in class we have methods, right? So if we are calling a method, for that particular method call, one thread gets created, ठीक है? Thread create होता है, and that thread gets memory into the stack area. Each and every thread will have memory that is stack gets allocated here into the stack area. That is known as runtime stack area, and that thread is known as runtime thread. You can say currently executing thread. Okay, so the thread, suppose you have n number 3 methods in your class. Okay, so for first method, suppose that method is for example, I am saying add, subtract, and multiplication. All these 3 methods are there. So for these 3 methods in my class, whenever I am calling these methods, each and every method call will have a separate thread created, and memory gets allocated for these 3 different threads. Okay, into the stack area. So what they are storing, suppose add method has some information like variable है, ठीक है? Suppose I have variable I and इसका कुछ value है. So these are known as local variables. The local variables are stored here into the LVA, that is local variable array. Okay. So for add method or add thread, the memory gets allocated separately. The variables get stored here into the local variable array. If we are performing some operation or calculation like we are doing here, return my psi. Okay. So I am calculating here. So whatever the operand we are using, this data gets stored here into the operand stack to perform this calculation. And whatever the data we are returning from this method, that gets stored here into the frame data. Okay. So for each and every thread, this is for add method, thread 1 gets created, and we can say add thread gets created, and the data is stored here into this particular stack area. For subtraction, we have created another method. We have called that method. The same for this also. Suppose it has another variable and it is returning. Okay, so the local variable gets for subtraction call, the another thread gets created, another memory gets allocated where the local variable gets stored here into this particular or associated local variable array के लिए जो भी memory allocation हुआ है वहां पे store होगा. Then the operand again stored into the operand stack, and the return value, if this method is returning something, that return value gets stored here into the frame data. So we cannot access add method or add thread into a subthread or subthread into add thread. Okay, we cannot access it. It is associated only particularly for that thread itself. And once the execution completes, so once the program is completed, add method call is done multiple times, your program is stopped. That time this memory gets freed automatically by the JVM by deleting the data stored into this threads. Okay, clear? As these are storing data differently or separately, we are not able to access these data from one thread to another. That is why the data stored here is thread set. Clear? Understood? Okay. Now the next is fourth part here into the data area. Runtime data areas is PC registers. Okay, and native method stack. What are these two? So there are different PC registers for different threads. For thread 1, the PC register is different. Thread n तक कितने भी आप use कर सकते हो, and what is method native method stack that we will see. So PC register, each thread will have separate PC registers. Registers are there in our system to store the data. Previously, when we were using assembly languages, that time we were storing the data directly into these registers. Okay. So internally, in our you can say in internally system has these registers to store the data. Okay. So to hold the address of the current executing instruction, once the instruction is executed, the PC register will be updated with the next instruction. What does this mean? So suppose your program has one line that is system.out.println. ठीक है, कुछ स्टेटमेंट है here. इसके बाद suppose consider that I am doing some addition. And I am again displaying the same here as the third line. Okay. This is my program. Okay. So what happens? This is under one thread. Okay, it can be add. So अभी हमने देखा था, suppose the add method is there and I'm doing this part here into the add method. Then what happens? So line by line instructions. The first line instruction gets stored here into the PC register. Directly, it will not store the data. Okay, whatever line you have written, that not get stored. What it will store? It will store the address of this line. Address of this line. So the whatever the memory address of this line is, that gets stored here into the PC register. It gets executed. Then the next statement's memory address is stored into the PC register for executing next line. So line by line of code execution is done in this way. कैसे होता है? PC register में each thread will have a separate PC registers, okay, to hold the address of current execution instruction. करंट एग्जीक्यूशन जहां पे आपका फर्स्ट स्टेटमेंट एग्जीक्यूट होने वाला है, उसका मेमोरी एड्रेस गेट स्टोर्ड. द वंस द इंस्ट्रक्शन इज एग्जीक्यूटेड, इट विल बी रिप्लेस्ड विद द नेक्स्ट instructions memory address. It is not actually storing the lines into the PC register. Lines नहीं store होते हैं. What gets stored? The address of that line, memory address of that line. So the memory from where this statement needs to be executed. ये कहाँ पे store होगा? If this is an instance method, it will get stored into heap area. And again, the memory call, whenever you're calling a this method, thread will get created and this data is stored into the stack area. Okay. If this is not the instance method, it is normal method into your class. Okay. Then this method is gets memory allocated into method area, but most of the time the methods are instance methods itself. ठीक है, तो इंस्टेंस मेथड्स ही रहेंगे. अगर नहीं है तो आपका हिप एरिया में ये इसके लिए मेमोरी एलोकेट हो गया. ऑल द इंस्ट्रक्शंस आर स्टोर्ड इनटू दैट हिप एरिया इटसेल्फ. ठीक है, सो दिस इज व्हाट डू यू मीन बाय दिस पीसी रजिस्टर, हाउ इट एग्जीक्यूट्स. Last one is the native method stack. So native method means suppose you are using Windows system and we are executing this on Linux system, any application, the same method call we are performing on the Linux system. So if this Linux has some native information that needs to be executed or stored here into the native method stack. So it is mostly related to the platform. Okay, the native method stack holds native method information for every thread, a separate native method stack will be created. That is means if this add method you are writing only for Windows system and you want to write a separate method for Linux system, that should be only gets executed on the Linux system. Okay, those methods are known as native methods. That means you are writing some methods which are nothing but platform dependent methods. Those are known as native methods. And whenever you want to execute these native methods, the memory gets allocated here into this native method stacks. Clear? So this is all 5 parts of your second runtime data areas. Clear? Runtime data areas is most important because every memory allocation part is stored here, how the memory gets allocated, where to get stored, everything is inside this runtime data area. This is the second most important part of your JVM architecture. Clear? Any doubt here? In an interview, you may get asked what data gets stored into method area. If I want to store the instance variables values, where those get stored, heap area. What is the difference between method area and heap area? You must understand these questions may get asked in the interview related to the memory allocations, memory management. So that is why we say that Java handles or Java is handling memory allocation automatically. You don't have to worry about the memory allocations. But for C and C++, you need to allocate the memory yourself. ठीक है? So ये memory सारे कुछ allocation, कौन सा data कहाँ पे जाएगा, कौन सा data कहाँ store होगा, that is done by the JVM itself. Clear? Shall we go ahead? Understood? Any doubt? Yes, I need a response from everyone. So 2 parts we have covered, class loader subsystem and runtime data areas. Everything is clear to everyone.
Yes, ma'am.
Okay. What about others? Yes, heap area is connected with runtime entities like objects. Temporary data means exactly what? So whatever the local variables are nothing but the temporary itself. Okay, so you can say that. Because local variables are whatever the data we are storing, that is locally available. The method is only for local purpose. Variables execution information. Variables, no, instance, object variables. That means instance variables. If the variables are static variables, we have already seen static variables are stored. Okay? And static variables are stored into method area. Normal variables are also class level variables are stored here into method area. If instance variables are there, those are stored into heap area. Okay, Jyoti? Clear? Okay. So next part of the JVM architecture, execution engine. तो सबसे पहले हमने क्या देखा? We have loaded our class .class file. We have verified it. If it is verified, the memory gets allocated. The initialization process for the static variables are done. Then the other variables, other methods, whatever we have into our class, for those memory gets allocated according to the different ways, like inside the method area or heap area. For each and every method call, the data gets stored here into the stack area. The instructions for these calls are stored here into the PC registers. Native method stack will have it only for the native methods, so no need to worry about this. Okay, so after this memory allocation and all these things are done, we need to execute our program. So, right. So whenever we are executing, this execution engine will come into picture. After loading, after memory allocation, your program goes into execution engine. So execution engine has three parts. First one is the interpreter. Second one is the JIT compiler. JIT compiler is nothing but the just-in-time compiler. And third one is the garbage collection or garbage collector. Okay? So this is the three parts of execution engine. One by one, we are going to learn. First important part is interpreter. As we have seen, one advantage of, or you can say feature of Java, that it is then compiled and interpreted language. What does this mean? So C uses only compiler, okay, and Java is compiled and interpreted language. So every program goes into two steps. First, it is a compilation. Second one is the interpretation. So interpretation will be done here into the interpreter by the interpreter itself. Okay, so ये थोड़ा सा summarized part है runtime data areas का. You can see here class data stored into the method area. What data gets stored? Static variables, static blocks, and references. Second is object related information. Object data to get stored into the heap area, instance variables, instance methods. Then the runtime stacks. It is nothing but the stack memory where method calls and local variables are stored. For these, each and every instruction is stored here into the PC registers. Okay, so this is the summarized part of the runtime data areas. Now, here the bytecode is generated. Dot class file is generated up, right? हमने load कर लिया है. We have loaded the dot class file, which is assigned to this runtime data areas for memory allocation. Will be executed by the execution engine. Okay, so bytecode which is generated will be executed by this execution engine. Execution engine reads the bytecode and executes it piece by piece. Okay, so what is the work of this interpreter? Interpreter interprets the bytecode faster but executes slowly. Okay, bytecode interpret करेगा. Interpret means we are translating, you can say. Okay, we are translating into machine code. Interpret faster but execute slowly. Execution will be slow. Why? Because line by line it needs to execute. Conversion will be done. Interpretation will be done faster, but executing line by line code is slow. We are going to see what is the different way interpreter, how it works in next points. Okay, what is the compiler and how it works, what is the interpreter and how it works in the next points we are going to learn. अभी के लिए सिर्फ interpreter JVM का जो काम करता है, JVM related information है, उतना आप सिर्फ ध्यान में रखो. ठीक है, so interpreter interprets bytecode faster but executes slowly. The disadvantage of the interpreter is that when one method is called multiple times, every time new interpretation is required. That is mean if I have this add method and I'm calling this add method multiple times, so for each method call, it needs to interpret the same lines of code multiple times. मतलब जो बाइट कोड है इसको मशीन कोड में कन्वर्ट करना है. मशीन कोड में कन्वर्जन for same method calls, it is calling or it is interpreting the same data, same lines of code multiple times. Okay, this is the disadvantage of interpreter. One method call is method is called multiple times. Every time new interpretation is required. Okay, this is the disadvantage of interpreter. Now, the JIT compiler. This is the second part of your execution engine. So first we will see what are the different subparts of the JIT compiler. So JIT compiler follows this algorithm, you can say. Intermediate code generator, or these are the subparts of the JIT compiler. Code optimizer, target code generator, and last one is the profiler. Okay, so JIT compiler has these four subparts: intermediate code generator, code optimizer, target code generator, and profiler. Code optimizer means optimization means improve the code quality and efficiency. Okay, so to improve the code quality and efficiency, this code optimizer will work. So how these 3 to 4 different parts are going to work in the JIT compiler, and why we need the JIT compiler. So JIT is nothing but stands for just-in-time compiler. Just-in-time compiler. Okay, it is short form for JIT. JIT is the short form for just-in-time. It neutralizes the disadvantage of this interpreter. Interpreter का disadvantage अभी हमने देखा. If you are calling the same method multiple times, then a new interpretation is required for each and every method call. So this is the disadvantage. And to neutralize this disadvantage, we use this JIT compiler. So what JIT compiler do? The execution will be using with the help of interpreter converting the byte code. Okay, byte code gets converted into machine code. But when it finds repeated code like this, repeated method calls, okay, it uses the JIT compiler. It uses this JIT compiler, which compiles the entire byte code and changes it to native code. Native code means this particular system related code. ठीक है, तो JIT compiler क्या करता है, अगर आपके मेथड कॉल्स मल्टीपल है या मल्टीपल रिपीटेटिव डेटा दिख रहा है, तो इसको नेटिव कोड में कन्वर्ट कर देता है. जो बाइट कोड है उसको चेंज करता है नेटिव कोड में. दैट मीन्स दैट विल बी stored directly into your system. So this native code will be used directly for repetitive method calls, which improves the performance of the system. Why? क्योंकि whenever we are using the interpreter, it bytecode conversion is faster, but it executes very slowly. If there are multiple method calls for the same method, then every time this interpreter is interpreting the data or the lines of code here written in the same method. Okay, the method is same, but in it was interpreting it multiple times. So what the JIT compiler do to overcome this, or you can say to neutralize this disadvantage of interpreter, it will convert, if it finds the multiple repetitive code or repeated code, it will convert that bytecode part into native code that will be stored locally. Okay? The native code will be used directly for repeated method calls. So for first time, whenever you're calling, this interpreter will interpret. ठीक है, नेक्स्ट मेथड कॉल के लिए आपको ये रिपीटेटेड कोड है, ये समझ में आया JVM को, तो for next method call it will changes this byte code into native code, and whenever you're calling that method again and again, third time, fourth time, fifth time, so rather than using this interpreter, the JVM uses the JIT compiler to directly use the native code, so that the interpretation is not required every time. It will improve our performance of the system, and it will use this JIT compiler directly to use this native code. Okay? So this is the JIT compiler. So JIT compiler and interpreter. How it works here, that we will see. So .java file, that is a Java source file. Compiler compiles that file, and .class file gets created, that is known as the bytecode. Okay? It is also known as metadata. So just-in-time compiler, once it is compiled, compilation occurs the first time a method is called, only if it's called. Okay? So this .class file goes to the JIT compiler. If the repetitive code is there, then the JIT compiler converts that into or changes it into native code and store it into cache in memory. ठीक है, cache in memory, cache memory में store होता है, you can say that. When it is done, it will be done at the run time. It will not be done at the compile time. Compilation के time पे नहीं होता है, run time पे class file से data byte code जो है वो JIT compiler use करके store करता है native code में, that is nothing but the cache होता है, cache memory में store होगा, which is locally available. So whenever next time you're calling the same method, the data, instead of going through all this part, it will directly load that from the cached memory. Okay? इट इज नथिंग बट आपने जैसे आप लॉग इन डिटेल स्टोर करते हो, आपका जीमेल है, ठीक है, इफ ऑन योर सिस्टम यू आर स्टोरिंग योर जीमेल email ID and password, and you are, whenever you are accessing your Gmail, it will automatically log in you, right? So automatically logging process is done. How it is done? Because you have stored this email and password. So whenever you're opening this gmail.com, it will be automatically logging you with your details. Similarly, why? Because these data are stored somewhere into your system, right? So somewhere into your system, that is, it can be into cache memory, it can be anywhere into your system. But similarly, this is also done. So if you're calling the same method multiple times, this bytecode gets stored into the cache memory as a native code, and that gets executed multiple times instead of again conversion of the bytecode and interpretation, right? So this is the interpreter and JIT compiler. So JIT compiler has 4 different parts. So अभी हम देख रहे थे, that is nothing but intermediate code generator. So intermediate code generator produces intermediate code, okay? Whatever the intermediate code is, bytecode to intermediate code. Code optimizer optimizes the intermediate code, and that will be improving the quality and efficiency of your code. Third one is target code generator. So it is responsible for generating machine code or native code. So this is target code generator is generating or converting your bytecode into machine code. Last one is profiler. It is a special component basically, and it is responsible for finding hotspot, that is whether the method is called multiple times or not. So the profiler work is what? If you are calling a method multiple times in your code, so the profiler will find it, and then according to that, it will inform the JIT compiler to store that or convert that into your what is that? It is nothing but the native code. Okay. So these are the 4 different parts of the JIT compiler. After the second part, after interpreter, after JIT compiler. So JIT compiler only comes in a picture when there is multiple repeated method calls. ठीक है, अगर repeated method calls नहीं है आपके प्रोग्राम में तो JIT compiler पिक्चर में नहीं आएगा. अगर एक ही टाइम आपने कॉल किया है तो JIT compiler पिक्चर में नहीं आएगा. It will never get used. Only the interpreter will be used. But any program or any application has the multiple method calls. ठीक है, repeated method calls रहता ही है. That is why JIT compiler is important. In interview also you may get asked what is JIT compiler and why we need it. What are the different advantages of using JIT compiler that I have already explained to you. Okay. Last part of the execution engine is garbage collector. As we have seen, memory allocation and memory allocation is done automatically into Java using JVM's architecture, right? Similarly, it collects and removes unreferenced object. Okay, so garbage collection is nothing but freeing up the memory. You can say deallocating a memory done by the JVM automatically to maintain the values, or you can say maintain the memory management. Okay, memory management will be done JVM itself by allocating a memory and deallocating a memory. So deallocation will be done as a garbage collection. The term is garbage collection. Okay, and this garbage collector is responsible to collect and removes unreferenced object. जिसका कोई reference नहीं है, जिसका कोई अभी use नहीं है, those are gets removed or the memory gets freed using the garbage collector. Okay, the concept is garbage collection, and who does that? The garbage collector is doing that. Okay, so it collects and removes unreferenced objects. Garbage collection can be triggered by calling. If you want to do programmatically, then you can call system.gc. It will call garbage collection. Okay, this method gets called automatically. You don't have to do, but if you want to do it, then you can use this method. Okay, otherwise not. बट द एग्जीक्यूशन इज नॉट गारंटेड। ठीक है, तो एग्जीक्यूशन गारंटेड नहीं है, बट आपको करना है कभी तो आप इसको यूज कर सकते हो। So garbage collection of the JVM collects the objects that are created. Objects जो है, जो unreferenced है, उसका memory free करने के लिए garbage collector काम करता है. The concept is garbage collection. Okay. So garbage collection, the objects that are no longer used in memory and objects that which are unreferred are deleted from the memory and memory is freed automatically. Deallocation of the memory. Okay. The garbage collector call the finalize method to release the resources held by the object before the object collection garbage collected. Okay. That means if any resource like any file is holded by that object, file reference, etc. are holded, any resources, database connections are there, database is open. So those needs to be closed first, those needs to be released. That is why the garbage collector finalize method को call करता है before garbage is collected. ठीक है. So the method syntax is protected void finalize. Whatever the, you can use this method in your code also, but when it will get called, automatically it will get called when the garbage collection is done. ठीक है. So इसको आप सिर्फ लिखना है तो लिख सकते हो to release the resources, but it will get called automatically. You don't have to call it. Okay. Clear? Garbage collection concept. So we have seen these three parts of the JVM architecture: execution engine, interpreter, JIT compiler, and garbage collection. Clear with this? So we have covered all the main parts of your JVM architecture, that is class loader subsystem. Second one is runtime data areas and how it gets executed, those part, how the garbage collection is done, how the memory gets allocated, how the memory gets deallocated automatically by the JVM that we have seen till now. Clear with this? Last 2 points, the two parts are there: native method interface and native method library. As the name suggests, these are related to the native, that means system related information के लिए ही है, particular platform के लिए ही है. ठीक है. We will see these parts in short. ठीक है. But these three parts are most important, that is class loader subsystem, runtime data areas, and execution engine profiler. Okay. So the work or the profiler is responsible to find out the repeated code is there in your system. Okay. If you have the repeated code in your program, that is identified by this profiler and informed to the JIT compiler to simply create the intermediate code from that byte code, optimize that code, and then convert it into machine code and stored as a native code. That is the work of the JIT compiler. Okay. So profiler is only responsible to find out whether your program has repeated code, repeated method calls basically. Clear? Understood? Any doubt in this JVM architecture? Okay. So last 2 points, last two parts, that is Java native interface. It is known as JNI, and it will be interacting with the native method libraries. जो हमने native methods के लिए memory allocation देखा, native methods के लिए memory allocation कहाँ होता है? That is get stored into native method stack, right? Those are simply used only the same platform. आप एक particular platform के लिए यही method लिख रहे हो, उसी मेथड के लिए नेटिव मेथड्स आपको एग्जीक्यूट करने के लिए कुछ लाइब्रेरीज लगने वाले हैं, तो वो लाइब्रेरीज, नेटिव मेथड लाइब्रेरीज are there in your system, and it provides the native method libraries required for the execution engine, which are specific to hardware, as I said, specific to platform or hardware. ठीक है. So JNI will be interacting with the native method libraries. Native method libraries क्या है? So this is the collection of the native method or native libraries which are specific to your particular सिस्टम प्लेटफॉर्म, ठीक है, विच आर रिक्वायर्ड फॉर द एग्जीक्यूशन इंजन। कुछ लाइब्रेरीज प्रोवाइड होते हैं उनको यूज करने के लिए, उनको इंटरैक्ट करने के लिए। इंटरैक्शन क्यों जरूरी है? बिकॉज इफ वी आर राइटिंग सम नेटिव मेथड्स, then those are store if we are writing the methods, we need these libraries to execute. Okay, so these are interaction के लिए JNI use होता है। Clear? Okay then, so we have completed our JVM architecture. Those who have not installed Eclipse, please install it, and JDK also, so that we can start your programming. So from tomorrow, we will be starting basic concept and we will start with your programming. Okay. Okay, everyone. Any doubt you can ask? Otherwise, we will end our session. Anything?
Yeah, Jyoti, there will be 2 classes in a week.
Okay. Thank you, everyone. We will continue next.
Coding part will be starting after the leveling of all the interns at the same level.